Alright, 2.8, the distributive property of mathematics, is all about simplifying these same algebraic expressions we've been talking about, except this time we're adding another tool that we can use to do our simplification. The distributive property. Today's objective would be, if you're looking at your guided notes now at home, students will be able to simplify algebraic expressions using the distributive property of mathematics. Now, what is the distributive property? Let's say we encounter a situation like this in math. Let's say we encounter something like this: 2 times 4 plus 2. So our parentheses would tell us normally that we got to add this 4 and 2 together first, which would give us 2 times 6, and then we multiply 2 times 6 for a total of 12. Now, in algebra though, we might see something like this: 2 times x plus 2. And we don't know what x is. So we can't add x plus 2 because we can't simplify. These are not like terms. X and 2 is a constant. We cannot add those together because we can't simplify them. So to simplify this is when we use the distributive property of mathematics. And the distributive property states that the sum of two numbers and a third number is equal to the sum of those two numbers times that number outside parentheses. Now, let me explain this. This means that x plus 2 times 2, I distribute this 2 that's outside the parentheses. This means I can go like this. 2 times x plus 2 is the same thing as multiplying this 2 by the x and multiplying this 2 by the 2. I'm distributing this 2. So this is the same thing as saying 2 times x plus 2 times 2. So I've brought this 2 around to multiply it by both the x and the number 2. So we'd end up with 2x plus 4 as our simplified representation using the distributive property. Let's do a few more examples. Let's say I have the first one on that sheet. It's going to be 3 times 5 plus 2. Normally I would just say, okay, 5 plus 2 is 7, so we could do 3 times 7, it would be 21. Alternatively, we could do it that way. We'd end up with 3 times 7, a total of 21. Or we could do it like this: 3 times 5 plus 2. Let's do 3 times 5, it equals 15, plus 3 times 2 equals 6. 15 plus 6 also gives us 21. So no matter which way we did it, we got the same answer. We know that it's the same technique. But when we start adding variables in, that's when it gets tricky. So let's say we have this one here: 3 times x plus 4. I'm going to distribute the 3, bring down our same plus sign, and then distribute the 3 to the 4 as well. 3 times 4 would be a total of 12. So when you distribute this, we end up with 3x plus 12. Now, last example. Sometimes you're going to see positives and negatives. As with any math problem, you got to be ready to see those. Let's do this one. It's a tricky one. Negative 5 times 2x minus y. So basically, here's my sign, right? We're subtracting a y here. I got to distribute the negative 5 times 2x, and I got to distribute the negative 5 times a negative y. We're taking away the y. So negative 5 times 2x. That's going to be, if I start with 2x's and I multiply those 2x's by 5, I get a total of negative 10x's. And then I start with negative 5 and I multiply a negative 5 by a negative y, because we're taking away this y, we're subtracting it. I'd end up with positive 5y. Now, I kind of jumped steps there. If let's look at it what we did. Negative 5 times 2x equals negative 10x. Definitely we know that. But really, if we slow this down, let's do it like we've been doing it before. We keep our subtraction sign, because in the other ones we brought down that same sign. And then all I did was do a negative 5 times a positive y. You can think about this as a positive y. Negative 5 times positive y would be negative 5y. And then look, we have a subtraction sign and then a minus sign or negative sign. And when we subtract a negative number, it's the same thing as adding. So that's how I got that plus sign there. Alright, and again, the last thing to keep in mind is when we talk about simplifying, in order to add or subtract, we have to have like terms. But if we are multiplying or doing division, we do not need like terms. We can do 3 times x, as we've done, which equals 3x. We could do 2x times y, because when we put variables together, we know it's the same thing as multiplying. So I can write 2x times y as 2xy.